All right. So, do you guys remember doing equations with variables on both sides?
Yeah.
Like last year? Like, do y'all remember one solution, no solution, infinite solutions? Does that sound familiar at all?
Oh, yeah.
Okay. So, I know that they showed you like what you would see in a final answer, but I want to show you what it looks like in the calculator. So, a couple of weeks ago, when we solved equations with, like two-step equations, I told you guys that to check your answer, you could put the left side in y1 and the right side in y2, and we got negative x minus 1. And then when we look at the table with second graph, we look for, the answer is 1. So I think the answer is 1. So if I look at 1, I see that y1 and y2 are equal. So that's how I can check my answer. Now, we didn't look at the graph, but the graph is why we call this one solution, no solution, infinitely many. When you guys started this in 7th grade, I think you called them simultaneous solutions, and simultaneous means happening at the same time. So that means the x value that they have at the same time. So what is the x value and y are the same? That's called a simultaneous solution. In 8th grade, they start calling it systems, but they don't tell you what it means. And in algebra, we actually have a whole unit on systems, on linear systems. And there's more than there's not just linear systems, there's all kinds of systems. But what a system is, so like if I think about like the solar system, right? The solar system, we have all these stars, right? And they're moving together, right? If everything goes right, they don't like interact with each other, right? We never interact with each other. But occasionally like an asteroid will pop out of one of the asteroid fields and it'll like start orbiting. So it'll come loose and it'll start orbiting, and then maybe it hits one of the moons, it hits a moon, or maybe it hits Earth, but probably not, because we wouldn't have to worry about anything after that. But anyway, so in our solar system, we don't want anything to interact. But in a system of linear equations, things do interact, okay? And we have two lines, and we're looking at how they interact with each other. So what this is, if you look, this is an mx plus b formatted equation here, and so is this. So we have put two linear equations in. So if I look at the graph, this is going to graph like, this is the 2x minus 4, this is the negative x minus 1. These lines cross in one place. They cross at 1, negative 2, which is where I found my solution, at 1, negative 2. So the solution to an equation with variables on both sides is where the two lines cross, okay? So the two lines, if you get x equals something, that means those lines crossed when x was that value. So if x is 5, that means that x equals 5, those two lines crossed each other. What was on the left and what was on the right, when we graph them, they cross. Okay, now, let's look at this one here, this no solution guy here. Okay, so if I change this, the first equation stays the same, but the second one's going to change. So I have 2 parentheses x plus 1. Now, when I graph this one, take a look at what happens when I graph this one. So there's my first line, same as before. Here comes my second line. Now, what do you notice about those lines? What are they? They're parallel, right? So are they ever going to cross? No, and remember, I just said that the solution is where the two lines cross, but if they never cross, they never have a solution. Ideally, that's what we want in our solar system, is we want nothing to cross our path. Okay, we don't want to cross anything's path, we don't want anything to cross our path. The solar system is all about no solution, all right, because we don't want things crossing, hitting. Okay, so that's why this has no solution, because this equation and this equation, they're never going to have a value where they're equal, because they're going to be parallel, they're going to be running next to each other the same distance apart forever. So they're never going to cross. Now, I know it's so sad, right? It's like Romeo and Juliet up in here. All right, so now if I look at the third one, again, the first equation stays the same, but now I have 2 parentheses x minus 2. Now look at this graph. Now watch really, really carefully. Okay, watch really carefully. See, there's the blue line. Now watch for the red line. Did you see it? Those two lines graphed right on top of each other. Now, that's why we call it infinitely many solutions, because a line has infinite points. And if I have two lines crossing at infinite points, then they're going to have infinite solutions, because there's infinite places where they cross.
So does it happen when you use the second table?
Huh? Yeah, and in second table, what you see there is you see every y1 and y2 is the same, because every point at -6, they have the same point. At -5, they have the same point. At 0, they have the same point. Every place the y1 and y2 are the same, because they're two lines graphing right on top of each other. Okay? So this is why we have one solution, no solution, infinitely many. Okay? We're going to learn about parallel lines next week. We're going to talk about systems. Systems are the unit that we take right before winter break. So we're going to learn about systems in like late November. We'll start systems in late November. All right? But in order for us to be super successful at systems, we need to make sure that we are super successful at solving equations with variables on both sides. So that's why we're doing this now. It's a gap we want to fill so that we're ready. Okay? So let's take a look at this problem. So I'm going to solve this one with you first. Now, first of all, I don't like this negative x. Why don't I like that negative x? No, that's actually not why I don't like it this time. There's no number. It's naked. We can see its business. Okay? So we're going to cover it up. We're going to give it a 1 in front of it so that its business isn't all up in everybody's business. You know what I'm saying? Nobody needs that. Okay? So when you see one of these numbers, when you see an x that's by itself, so like right here, you could put a 1 right here too. You could put a 1 right there. Anytime you see an x that doesn't have a coefficient or a negative x that doesn't have a number, give it a 1, because that way you can make sure that, just let me show you why. Okay, so first of all, is this the class where we like the drawing arrows and moving them to Canada? Moving them to Canada? Never mind. Okay, well, whatever. Okay, well, all right, so let's solve this thing. So I look. Now, again, when you're solving equations, until you feel like a crazy freaking rock star on these things, I want you keeping these instructions next to you. So we're going to start by distributing, but I don't see any parentheses on this one, so I don't need to do that. Then we look for fractions, but I don't see any fractions. Then we look for terms to combine. Now, I see some stuff across the equal sign, but I can't combine across the equal sign. So I have a number, a letter and a number here, a letter and a number there. So I've combined everything I can. Okay, not yet. So now I'm going to get all my x's on one side of the equal sign. So I need to take my x's, I need to move them over there. All right? So how do I get rid of minus 1x? I add 1x. If I do it to one side, I do it to both. Okay, so now, the reason why I like to put a 1 here is because we get, especially, this actually becomes a problem when you start, when you get better at solving equations, because you start moving so fast that you make real easy little mistakes. If you have, so 2 plus 1 is obviously 3x. But if there's nothing there and you're going fast, you might go 2 plus nothing is 2, and just forget that there's an x there. Okay? So we want to make sure that we remember that there's an x there. This zeroed away, and I have negative 1. All right? Okay, so now I'm done with step 4. Step 5, this is like what we did before. It says get 1x on the other side of the equal sign. So I'm going to move that over there by adding 4 to both sides. This zeroes out. I get 3x equals 3. Last step says to divide by whatever's in front of x. So I get x equals 1. And remember, that's where we saw our solution at x equals 1, negative 2. At that coordinate 1, negative 2, that's where they crossed. 1, negative 2, in the table is where they crossed. Okay? If you see x equals anything, if you see an x, then you have one solution. Okay, you have one solution. Period. All right? Questions about this one? Was that one okay? Okay, let's look at the next one. Okay, the next one, ooh, look at that. I see distribution. All right? Now, the biggest mistake I've been seeing people make all day is instead of multiplying, they're adding. It's 2 times 1, well, first of all, let's bring all these leftovers down. 2 times 1 is 2x. 2 times 1 is positive 2. We are not adding them, we are multiplying them. Okay? I'm seeing a lot of people put 2x plus 3 or forget and just put 2x plus 1. You have to multiply both everything inside by whatever is outside. Okay? All right. So far, so good? Okay, I am good all the way down to getting my x's on one side. So I need to take this 2x and I need to get it over there. So I'm going to subtract 2x from both sides. So this zeroes out. But doesn't this 2x minus 2x, this zeroes out too?
So it's not, if you don't drop down like an x?
Well, there's no x to drop down. It's gone. They zeroed away, right? So all I have left is negative 4 equals 2. What?
We don't have solution.
Plus 2?
So, okay, so here's the question you ask. Does negative 4 equal 2? Does negative 4 equal 2?
No.
No.
Is owing $4 the same thing as having $2? No. So negative 4 does not equal 2. And if the answer is no, I have no solution. Okay? Sometimes you might see this written as no real solution. We're going to talk about real numbers, and we're just going to talk about that later. Okay, that's tomorrow's problem. That's some other time's problem. Okay, but we will talk about it. Okay, so again, when you get to this point, when you have no x's left, but you just got numbers, so like all my x's went away and I got these numbers. So I'm like, well, does negative 4 equal 2? No, it doesn't. So there's no solution because that's not true. That's not a true statement. Okay, what do we think? You okay with that? All right. So then, does anybody immediately have a follow-up question? Like, you're already thinking of a question. What's the question that you're thinking?
Why don't you solve it?
It is solved. The question a lot of people start asking before I even get there is, but what if they are equal? Okay, well, I'm so glad you asked. Okay, so let's work on this one. This one again, we distribute the 2. And remember, we're multiplying. So over here I have 2x minus 4. 2 times 1x is 2x. 2 times negative 2 is minus 4.
Oh, they're the same thing.
What do you notice?
They're the same thing.
Does anybody else notice that?
Yeah.
I have the same thing. If I were to put these two equations in like I did before, they would graph the same line. That's why this has infinite solutions, because they're the same. Now, I can already see that they're the same. As soon as you see the exact same thing on both sides of the equal sign, I know I have infinite solutions. But just for the heck of it, if I subtract 2x from both sides, I get negative 4 equals negative 4. Does negative 4 equal negative 4? Yes. So I have infinite solutions, which sometimes you also see as all real numbers. Okay? This is how you know what your variables are when you have variables on both sides. This is how you know what those answers mean.